This is Mirrors by Celeste and Chelsea. Background on curved mirrors. If the edge is curved towards the observer, it is identified as a concave mirror. If the edge is curved away from the observer, it is identified as a convex mirror. Identifying what kind of mirror it is will be the most important task to do when drawing a ray diagram. Background on important words. 1. The radius of curvature is the distance from the geometric center to the mirror. Here's where the mirror surface is located. 2. Principal axis, the line through the geometric center and perpendicular to the surface. Here's where principal axis is located. 3. Real images formed when the reflected rays coverage. 4. Virtual images are formed when the reflected rays will not coverage. Extend the reflected rays behind the mirror so they can intercept. Real images will be seen in front of the mirror represented with a solid arrow. Virtual images will be seen behind the mirror represented with a dashed arrow. Keep in mind the image below. Positive means the front of the mirror, negative is behind of the mirror. Number 5, upright. The image's orientation is the same as the object. 6, inverted. The image's orientation is the opposite of the object. The words 3 through 6 are the words you can use to describe a ray diagram. Also, when you solve for the equation, you will be able to tell if the diagram matches with your algebra. Equations, variables, definitions, and units. The equation you should use when finding the location of either the image or the object is 1 over dO plus 1 over dI equals 1 over F. dO stands for distance of the object and the units are centimeters or meters. Di equals the distance of the image, the units are centimeters over meters. F is for focal length and the units are centimeters or meters. If the image distance is positive, then the image is real. If it's negative, the image is virtual. To find the magnification, the equation you will need to use is m equals negative di over do, or m equals hi over ho. M equals magnification and the units are none. Hi equals image height and units are centimeters or meters. Ho equals object height and the units are centimeters or meters. If m is positive, the image is upright. If m is negative, the image is inverted. Steps to take. 1. Underline your givens and what you have to solve for. 2. You can decide whether to draw the diagram first or solve the problem mathematically. 3. Make sure your diagram matches your algebra. Scenario problem. The object is placed 10 centimeters from the convex mirror with the focal length of negative 5 centimeters. Draw a ray diagram below to describe the image using the fundamental equation to find the location of the image and magnification.
On this image, our givens and what we have to find for are underlined in red. This is the image we are going to use from our scenario. The object is in front of the mirror, meaning it is positive. Draw a ray to the surface as if you were going to go through the focal point. Reflect it back parallel to the principal axis. You will then do the same thing, drawing a ray parallel to the principal axis starting from the tip of the object. Reflect it back in line with the focal point. As you can see, these two rays will never intersect each other, so in order for them to intersect, we had to draw dashed lines. Extend the reflected rays behind the mirror with dashed lines. Just like this. The object is upright and virtual. meaning it is negative, because it is behind the mirror. Our givens for the equation is DO, which is 10 centimeters. Our focal length is negative 5 centimeters using the variable f. Find the location of the image and the magnification, meaning DI and M. Start with 1 over DI plus 1 over DO equals 1 over F. Then, for magnification, M equals negative DI over DO. The givens for the first equation is DO equals 10 centimeters, F equals negative 5 centimeters. Plug it in and you will be left with this. You will then subtract 1 over 10 centimeters. Subtract so you can leave 1 over DI by itself. You will then be left with negative 3 over 10 centimeters. Since we can have DI as a fraction, you will have to do the inverse. Once you find the inverse, you will be left with negative 3.33 centimeters, round to 2 decimals. To find the magnification, your givens are DI equals negative 3.33 or negative 10 over 3 centimeters. DO equals 10 centimeters. You will then have to find M. This is the equation you will be using. Plug it in, and since there are two negative signs, the answer will become positive, giving you 0.33 with no units. The final answer is telling us that the image is virtual and upright, meaning it is behind the mirror, and the image is pointing up. If this matches the ray diagram, you did the problem right. The end.